So I'm going to go into how we can do partial fraction decomposition. So if we have this integral, x cubed plus x squared, right, over a polynomial x squared plus 5x plus 6 dx. We need to integrate that. Well, the first thing we're going to ask is this a simple integral? No, it's not a simple integral. Right? Second thing we ask, can we do u substitution? Well, we have u underneath, but the numerator is not the integral, is not the derivative of the denominator, so no, we can't do a u substitution. Okay, you can try, but you won't be successful. Right? So, and if we try to do integration by parts, things are going to generate more integrals that are also fractions, right? So what we want to do is we want to decompose this fraction. We want to turn it into something that we can integrate. Okay? So we're going to do that by performing the long division. Okay? So if we have x cubed plus x squared, over x squared plus 5x plus 6. Right, what does that mean? That means we're taking the numerator and dividing the denominator into it. Right? So because the degree of the numerator is higher, right, we can decompose this. And so I'm just going to start over here. Let's write x cubed. Make me some space. Oops. All right, so our numerator, right, x cubed plus x squared divided by, it's not enough space, x cubed plus x squared. We're going to divide into that our denominator, x squared plus 5x plus 6. Okay. So what we're going to do is we're going to start term by term. Right? The first thing I'm going to ask is how many times does the first term go into the first term? Right? So what does it take me to multiply x squared by to get x cubed? And that's simply x. Okay. Now I'm going to multiply across, okay, to get all of my values, right? So x times x squared is x cubed. So I did x squared to give me x cubed. Okay, now I go to the next term. Okay, I'm going to multiply x times 5x to give me plus 5x squared. And now I'm going to multiply x by 6 to give me plus 6x. And then just like in long division, you may remember from a long time ago, we're going to subtract. Subtract. Right? So x squared, x cubed minus x cubed is 0. X squared minus 5x is minus 4x. And 6x, essentially there's a 0 up here, right? Times x, right, as a placeholder. And that's going to be minus 6x. Okay, then we're going to do this again. We're going to ask what number, okay, what number do we multiply x squared by to get 4x squared? Okay, well, that's just negative 4. Okay. So I take negative 4, multiply it by 4x squared, I get minus 4x squared. Then I take negative 4 and I multiply it by 5x squared. And that gives me minus 20x. And then I take minus 4 and I multiply it by 6 to get minus 24. All right. Now I'm going to divide. So then I'm going to subtract this term. Now these are all negative values, so these are all going to become positives. Okay, so I'm going to be left with 0 plus 14x plus 24. Now, x squared does not go into 14x plus 24. Okay. You can see that. So we stop, and 14x plus 24 is the remainder. Okay, that whole value is going to be our remainder. Okay, so when we write out what our solution is, right, so the remainder is going to, just like in regular long division, we're going to put the remainder over our denominator. Okay, so this is going to give us that when we perform this division, x minus 4 plus 14x plus 24 over our polynomial x squared plus 5x plus 6. Right? Now, that's how it decomposes. Right? So now what we can do is turn this integral over here into that. So we're going to take the integral of x minus 4 plus 14x plus 24 over x squared plus 5x plus 6 dx. Now you can see we're closer, right? So now we've got an x and a 4 in there, and those are both things we can take an integral of. So now we need to do something with the 14x plus 24. Okay, so let's start with that over here. I have 14x plus 24 for x squared plus 5x plus 6. Now this came from somewhere, right? We have a sum up there, right? Some 14x plus 24. So we added some fractions. Okay, so we need to figure out what fractions we added. And we can figure this out if we can factor the bottom. All right, so if we factor the bottom factors to x plus 2, x plus 3. Right? We take x squared plus 5x and it becomes x plus 2, x plus 3. It means that was the common denominator. When we took our fractions, we added. So we had some value, a, we don't know what it is, over x plus 2, and we added to that some value b, and we don't know what that was, x plus 3. Right? And then when we made a common denominator, the common denominator was x squared plus 5x plus 6. Right? So now we need to figure out what those a and b's are. Because you can see what this has done. This has now reduced that polynomial into two terms, which we could integrate if a and b are simple enough. Okay, so how do we do that? Well, the first thing we want to do is get rid of this guy here, right? We want to get rid of x squared plus 5x plus 6. So how do we do that? Well, we multiply both sides, okay, by our fractions. I mean, our denominator here. Right? So if we multiply this side, x plus 2 times x plus 3, okay, then our denominator is going to cancel. This is going to cancel, and this is going to cancel. That. And then we have to do the same thing on the other side. Right? So now we need to multiply this side by x plus 2, x plus 3. Okay. Right, now we got to carry, we got a sum there, right? So we have to carry it through to both sides. This is where this process gets a little long. So on my left side, we're left with 14x plus 24. Now if I carry this through is equal to a x plus 2, x plus 3 over x plus 2 plus b, x plus 2, x plus 3 over x plus 3. Right? Now if you look, these are fractions and everything and all this stuff. So x plus 2 cancels with x plus 2, x plus 3 cancels with x plus 3. Okay. And we're left with 14x plus 24 is equal to a times x plus 3 plus b times x plus 2. Okay, I'm going to carry those through. So we still have 14x on the left. I'm pretty much not going to do anything to the left side. ax plus 3 times a plus bx plus 2 times b. Now I'm going to bring the x's and the a's together. So we have 14x plus 24, still on that side. So now ax plus bx plus 3a plus 2b. Okay, now I'm going to factor the a and b out of that x. And why I'm going to do that will be clear in 1 second. So we have a plus b, x plus 3a plus 2 times b. Okay. Now, if we take a look at what happens here, right? We have a 14 as the coefficient in front of x, and a plus b as the coefficient in front of x. And then we have 24, and we have 3a plus 2b. Okay, so what we're going to do is we're going to equate those two pieces. Okay, because doing that, right, we know when we sum the right-hand side, when we add a plus bx plus 3a plus 2b, we have to end up with 14x plus 24. So I'm going to say 14 is equal to a plus b, and 24 is equal to 3a plus 2b. Now here we have a systems of equations, right? And you can pick your favorite method to solve, right? Plug and chug, do a subtraction, all right? Use your calculator. All right, but what I'm going to do very simply is I'm going to recognize from this one that b is equal to 14 minus a. Okay? And then I'm going to plug that in down here. And let me give myself some nice writing room. Okay? I'll zoom back out in a second. So we take that, we have 24 is equal to 3a plus 2 times 14 minus a. Okay. Let's see, that means 24 is equal to 3a plus 2a, 3a plus 28. Come on, 8. Okay, 28. And then 2 minus 2 times a. So that simplifies. We subtract 28 from both sides. So we'll have 24 minus 28 is equal to 3a minus 2a. So that we get negative 4 is equal to a. Okay? And that's our value. Now that we know a must be negative 4. Okay? So we come back up, right? So we're going to use this value of a. Oops. And we're going to use this value of a in our equation here, right, to determine what b is. Okay? So if we take that, oops, then now we start with, oops, no. What we want to do, okay, was it 3a 24? And 3a plus 2b. Okay. We want to take this guy here to determine what b is. So b is 14 minus 4. Minus a negative 4, so b is 18. Okay, now we have b and a. So we can zoom back out. All right, and we did all that work so that we can say that we know for certain that this up here is a over x2. Right? We get negative 4 over x plus 2 plus 18 over x plus 3. All right, so that's what that division gives us. So now we come all the way back over to what our integral was. All right, we're going to use that. Okay, so now we have the integral of x minus 4 plus, I'm going to write the 18 first just because it came to mind first, x plus 3 plus negative 4 x plus 2 dx. All right, now those are all simple integrals. X I can integrate. Right, so now I perform my integration. 1/2 x squared minus 4x plus 18 times the log of the absolute value of x plus 3 plus negative 4 times the log of the absolute value x plus 2 plus c. And that is my solution. So you can see these are quite long. There's a lot of places to make some mistakes. You got to just take your time and work through them. All right. Get ready to do some of these in class.